We are going to be looking at problem number 14. This is from section 3.3, chapter 3, section 3, problem number 14. In this particular problem, we are looking at piecewise defined functions. To graph a piecewise defined function, I first of all have to get my pointer ready here, and ink color, let's do this one in, I like dark green this time. What we need to do is we need to graph the two different pieces. Now this is called a piecewise defined function because it is defined differently for different values of x. So if x is less than or equal to 2, we see that the function is defined to be 3 minus x. If x is greater than 2, then our function is defined to be x squared. Let's take values that are less than 2. If I take some values less than 2, we could take a value such as, say, 0. 0 is less than 2. If I substitute 0 for the x in this formula, 3 minus 0 is 0, so that gives me a point over here, if I can get my cursor right, over here at 0, 3. Let's choose another value of x that is less than 0. Let's choose, say, less than or equal to 2. We could choose x equal to 2. If x is equal to 2, then 3 minus 2 is going to be 1. So we get a point over here at the point 2, 1, so that's approximately right here. Let's choose one more value. Let's choose, say, negative 3. If x is negative 3, that's less than or equal to 2. So 3 minus a negative 3 is going to be the same thing as 3 plus 3 or 6, and so we're going to get a point here at 3, 6, and see if I can get that approximately right. So for this portion of the graph, we are going to have a linear function that's approximately going down like so. But we're going to stop here at x equal to 2 because that's the end of this piece of the function. If we take values that are greater than 2, we could take a value, for instance, such as 3. If x is equal to 3, then 3 squared is 9. And so when x is equal to 3, we're going to get a value of 9. So that's going to give us a point. Let's see if I can get that approximately right, about right there. If I take x equal to 4, 4 squared is 16, so if I look at that, 16 is going to blow off the top of my graph, but I'll put a dot approximately where I think this is going to be. Maybe not quite tall enough. Now one thing I'm going to do, even though I don't have 2 as part of this piece, I'm going to evaluate this at x equal to 2 because that tells me where it stops. If x is equal to 2, 2 squared is 4. But instead of putting a dot at 4 or a point at 4, I am going to put an open circle here. So I'm going to have an open circle here because this tells me where the function stops. Now this is not quite what I want because this is supposed to be somewhat parabolic, and so this is not supposed to be a line. It's supposed to be parabolic, and graphing with this, it didn't work too super well, but you get the idea. The next part of this, part B, we want to find f of 2. Well, f of 2, I'm going to take not this part of the function, but this part, because this is where we have the equal to 2. So at x equal to 2, we're going to get a value of 1. So f of 2 is equal to 1. That corresponds to our point that we had over here. If x is equal to 3, that corresponds to this portion of the graph because of the function, because 3 is greater than 2, so I'm going to take 3 squared and we're going to get a value of 9. And finally, it says state the domain of the function. The domain of this function is going to be all real numbers because no matter what the x value is, we can get an output value. So the answer for this is going to be all real numbers. If we put this in interval notation, this would be from negative infinity to positive infinity. And sometimes we can use a symbol like a fancy script R, which I can't write, so I write a double bar R here. So that is completes this particular exercise, and hopefully you have a little bit better understanding of a piecewise defined function.